live in the office. Gotta go grab some trichoderma and bacillus subtilis because that is what we're going to be talking about on this particular live today. So you might be asking yourself, what is trichoderma? What is bacillus subtilis? So we'll start with trichoderma. So trichoderma, I'll show you, is a fungal, well, this is a fungal spore right here. You can see we've got a box of them. This is what the packaging looks like. And trichoderma is known for its ability to outcompete pathogens. This is extremely true and often seen in things like mushroom cultivation, where if the mushroom substrate accidentally comes in contact with trichoderma, it will actually ruin the whole process. And the reason why is because trichoderma itself is very, very good at acquiring nutrients and resources. It does it better than a lot of the other microorganisms. And so one of the ways that it outcompetes pathogens is just through being better at acquiring the natural resources in the environment. Besides that method, the trichoderma also produces antimicrobial compounds as well. So compounds like chitinase, right? Chitinase is an enzyme that degrades the cell walls of other fungal organisms. They also produce non-specific and sometimes specific antimicrobial compounds as well that will actually target competing microorganisms. One of the benefits that you get that is often not talked about is that trichoderma will actually make a plant root associations, just like our arbuscular mycorrhizal fungus. It will penetrate the root cuticle, and it will actually feed the plant and help transport things like phosphorus and water. And so it works, as a secondary root system. And anytime that the root makes, or the fungal hyphae makes an association with that root, it's essentially increasing the surface area of that root system, which enables the acquisition of more nutrients and water. Now, one of the cool things about the trichoderma is that it also produces beneficial plant compounds like phytohormones. So things like indole-3 acetic acid, which is something that is commonly used in rooting hormone. The synthetic version of that is IBA, which you'll typically see in like your cloning gels or your cloning powders. So it naturally produces the plant auxins. It also produces things like cytokinin and gibberellins. But one of the things that trichoderma is really known for is for the production of what are called hydroxamate sidiophores. And hydroxamate sidiophores are essentially these carbon compounds that are chelators. And so they have a high affinity for iron. So the benefit that you get is when you use something like trichoderma in your soil system, you'll have a higher bioavailability of iron and higher uptake of iron. And typically what you'll see in any system that has good soil structure is that iron oxidizes really easily, and it's converted from its ferric form to its oxidized form, which is far less available to the plant. So when you're inoculating your substrates, your soils with the trichoderma is producing those sidiophores and grabbing on and keeping those nutrient elements bioavailable. So it is not just about suppressing pathogens, but looking at specific microbes and consortiums of microbes that interact synergistically together to do multiple things. So cycling nutrients, outcompeting pathogens, and producing beneficial plant compounds. Now, I like to use the trichoderma in conjunction with the bacteria Bacillus subtilis. So this is a fungus, and it will produce the fungal filaments or the hyphae that are distributed throughout the soil system. The cool thing is that the Bacillus subtilis is much smaller and will actually colonize those fungal filaments, those hyphae. And so these microbes, they work synergistically together and they produce very similar metabolites. So just like the trichoderma, the Bacillus subtilis also produces specific and non-specific antimicrobial properties. It also produces enzymes like phosphatase, amylase, chitinase, and all these different enzymes. They actually do different types of work. So amylase and cellulase, those will break down organic matter, liberating the nutrient ions. Things like the chitinase will help degrade insect exoskeletons that are decomposing in there. They also decompose other types of fungus, the cell walls. So it helps with nutrient cycling as well. They also produce the hydroxamate sidiophores. And because they work synergistically together, when you use them in conjunction with each other, you get what's called dual efficacy. So the efficiency that one produces is exponentially increased when used together. So I highly recommend the Bacillus subtilis and trichoderma if you're growing outdoors. Things like tomatoes that get bottom end rot, which is usually a combination of not having enough calcium, but also a fungal disease. Different types of blight, fusarium, pythium, leaf septoria, botrytis or bud mold, powdery mildews of all sorts. Spraying and drenching your media, especially if you're outdoors. You know, I'm in an area in the Midwest where we have a lot of oak trees and a lot of trees in general, and leaf septoria is kind of ubiquitous to my environment. Now, if I do not, pre-treat my soil and do spray and drench applications throughout the season, what'll happen is that leaf septoria will create all the spotting on my leaves, and you'll start to see those leaves drop, which can decrease, both quality and the yield. So thanks for joining, everybody, first of all. Does it help with iron uptake? It does help with iron uptake. And that's the reason the reason why I looked at a wide variety of different types of microbes and microbial consortiums that functions. I'm looking not at just the microbe itself, but I'm doing research on what type of metabolites they are producing. And I say this all the time. When you're thinking about, let's say, cannabis, you have different types of terpenes and flavonoids and thiols and terpenes, cannabinoids, might have repeated myself. And those, they vary from variety to variety. And the same thing can kind of be said for bacteria and fungi. They're producing a lot of the same chemicals, but in different levels, right? So I'm looking at the metabolites because that's what's doing the biochemical work in the soil. A good example of that is going back to the sidiophores, right? If you have a microorganism that's producing a wide variety and a lot of different types of sidiophores, you're going to get the complexion with the nutrient ions in that soil, whether it's iron or zinc or copper. They can bind with a lot of different types of nutrient elements, and what happens is it keeps them from oxidizing in that soil. So it keeps them in a reduced form, which is the form that the plant can take them up. And when they're attached to carbon or carbon chelated, the plant is also taking up that carbon as well, and oftentimes those carbon skeletons can be used for other things that the plant is producing. Substrates. You can use it in any substrate. Hydroponics and soil and cocoa, living soils, potting mixes, it doesn't matter. Highly recommend it though. Does it kill thrips? No. There are certain types of microbes that will kill thrips. One of those is Beauveria bassiana. If that's something that you wanted to order, you can order the trichoderma or the bacillus and then ask to switch it out at the checkout on the website. But Beauveria bassiana has a wide range of insect targets, and it also is a saprophytic microorganism, just like the bacillus, subtilis, and trichoderma. While Beauveria bassiana kind of varies because it can utilize different forms or substrates, you could say, to proliferate. It can be an insect parasite, but it can also be a plant symbiont. It can be a saprophytic microorganism, so a free-living soil microorganism that's living off of decayed organic matter. It can also go through fermentation. Looking at the different modes of metabolism that microbes can go through is one thing that'll determine what types of microbes are in your system. But really, when it comes down to it, it's all about the metabolites that those are producing. So in the case of Beauveria bassiana, they release a few enzymes in abundance, and that's chitinase and another chitin-degrading enzyme. I can't remember the name of it off the top of my head. But both of those enzymes work to actually dissolve the exoskeletons of insects, and then what happens is once it has access, it can get into the actual circulatory system of the insect. And so what's happening is the spores are releasing the chitinase, and then that spore actually infects from the inside those insects, and then it causes what's called white muscadine disease, where you start seeing it's a cordyceps, so it's kind of, you start seeing all the little fungal filaments popping out while it parasitizes that insect. Now, let's say it parasitizes an insect, it creates spores, it releases those spores into soil, but those spores don't come in contact with another insect, but they are coming in contact with like compost or leaf mulch that's decomposing in that system. The fungus will kind of change, and it will start using different enzymes like maybe a lipase, an amylase, or a cellulase to start degrading that compound so it can liberate the nutrients from that inorganic material. So microbes are great. When we're talking about biocrop steering, or when I'm thinking of microbes, I'm not thinking directly of, is it a bacteria? Is it a fungi? Is it, this, or is it that? I'm really thinking in terms of what type of metabolites are being produced by that organism, because those metabolites are, again, what do the biochemical work in the soil. And I can think of it like if you let's take cellulase, right? It degrades cellulose. So what it does is it produces this enzyme, and this enzyme acts kind of like a zipper. So all of these substances, like the leaf, it's actually formed, it's physically from, proteins, and it's got, calcium and all kinds of other things that are actually creating that structure. And what happens is these enzymes, they do work, like, and they kind of unzip all of those bonds, and while those bonds of carbon are being unzipped, it's also liberating all of those nutrient ions. So if it's micronutrients, or if it's nitrogen or amino acids, it's kind of separating those things from their base constituents of what those things are made from. And those reduced forms are the forms that both bacteria and plants are going to have access to. How often should you apply if growing outdoors? So what I like to do is I like to pre-treat soil before I plant. That way, if there's anything like fusarium in there or any type of other things, it'll kind of wipe those out before I plant. And outdoors, I'll use these throughout the season as a spray and drench, as a preventative maintenance. If you have insect pressure, the application rate, you should be doing it maybe once or twice a week. But as preventative, if you don't have issues, if you're just doing your standard integrated pest management, about once every 6 weeks is adequate. And the cool thing is, these do not have a carrier, so they're pure spores, as you can see. Most companies' products are diluted. These are not diluted, so you only need 0.15 of a gram per gallon of water for each of these. And each of these, if you're using both of these, this makes up about 50 to 55 gallons of concentrate. And the benefit of not having a carrier is that if you run into conditions like I do, where I'm at in the Midwest, growing outdoors, I could be in week 5 or 6 of flower and it'll fucking rain. Now, even though my plants may not have any type of bud mold or anything like that, the conditions after it rains allow for those things. And again, these microorganisms are ubiquitous. They exist everywhere in the environment. It gives the conditions are ripe for those things to infect. So I will spray even if it is in flower. Now I don't do this usually indoors because we're not dealing with the same environmental factors. But if you're dealing with wet weather and you're in foliar and flowering, you can spray these and not worry about leaving any type of residue because they are pure spores, which means you're only delivering the microbes to prevent things like the botrytis or the powdery mildew when you run into those types of conditions. Sulfoyl X is a good, broad spectrum insecticide and fungicide. Is it best to apply at night or early morning? It is best to apply when it's a little more humid out in the morning or when the sun's going down. That way you're not dealing with direct UV light right when you're spraying these things. But honestly, I really haven't seen that much of a difference. But we are talking about microorganisms, and we know that if we give them the right conditions to proliferate, they're going to do it much easier. So when it's a little bit moister out and there's a little more access to water, these things will proliferate a little easier. Are most liquid enzymes like hydrozyme, SLF, a waste of dough compared to using fresh castings? Well, you'd have to see what those enzymes actually are, because I'm not sure if they're actually listed what enzyme it is. Because when we're talking about enzymes, an enzyme is a protein, and there are literally millions of different types of fucking enzymes in the world. So it depends on what type of chemical work that enzyme actually does. Because, again, when we're talking about the enzymes that are being produced by microorganisms like phosphatase, for instance, that enzyme is going to work on substrates that contain phosphorus, and it's going to liberate the plant available phosphate. If we're talking about cellulase, we're talking about an enzyme that's going to degrade cellulose. If we're talking about, so it depends on the enzyme, because that enzyme will do something specific. You know what I mean? So if you don't know what that enzyme is and they're just saying, hey, it's enzymes, it's good, without giving you an example like I just gave you, well, then it might just be fucking snake oil. I don't fucking know, because I don't really use those products. The products that I cultivate is the products that I promote and teach you guys about, because in my system I take a very science-backed approach, data collection, and taking a holistic approach that isn't just nutrient management, but managing the microbiome and the amount of carbon that's in these systems, because that's the way it has to be done if you're doing a whole holistic, if you're looking at something holistically like this. So, and here's the thing, all of the types of natural farming practices I do on outdoor stuff. So I'm not doing K&F stuff. I'm not doing composts. I'm not doing castings on my indoor stuff. When I built my soil for indoor, it was built at the maximum way that I could. So it already contains enough carbon. It already has the right porosity for maximum gas and water exchange. It's already loaded up with mineral-based nutrients and meal-based nutrients. And I don't, so I don't add more castings. I don't add more compost because there's really not going to be a net benefit when my soil's already properly built. It already contains a massive amount of carbon. I use all those types of things, the compost, the teas, all that on my outdoor, because my outdoor soil is not like the indoor soil that I build. It's real agronomic earth. So it works a little bit different. What's up from Arizona? We're out here in Oklahoma doing the thing. Big ups to everybody. Thank you guys for joining. Is there still a place for seaweed extract as a source of micronutrients? This is a really good question, and this is something that I was actually talking about the other day. First of all, seaweed extracts, kelp, I do not use those in my systems. Now, I used to, but when I started doing data testing and when I started sending materials off for heavy metals testing, what I saw consistently across the board with most brands is that their ocean inputs, whether it's things like crustacean meal, oyster shell flour, kelp meal, kelp extract, usually contained high levels of heavy metals and also high levels of both sodium and chloride. Now, if you're using your soil once and you're just adding these in small quantities, it might not make a difference. But if you're someone like me who constantly reuses my soil in like a no-till system or living organic system, if you constantly use those types of inputs, what happens is they start to build up over time. And so maybe a couple runs in, you start to run into issues, even though you haven't changed anything and you can't figure out, hey, what's going on? It's if you were to look at the data, you could see, oh, my sodium level started to go up, or the arsenic levels or cadmium levels started to go up because of these products. So, the pros versus the cons when I'm thinking about nutrient inputs, especially ocean inputs, the cons typically outweigh the pros. In the case of kelp, the actual nutrient profile, the complete nutrient profile, NPK, secondary, and micronutrients, is incredibly low compared to other things that are available. It's also the amount that you'd have to use to get adequate fertilization from kelp meal would bring in just so much bad stuff that it would really mess the system up. So what's in my hands, these are vials. This is trichoderma and bacillus subtilis. These are on the website. This is what I originally started this live to talk about, and I can review a little bit about the stuff that I'm talking about. First of all, these things are flying off the shelf. If you're grown outdoors like I do, because I do vegetables, I do cannabis, I have leaf septoria, and sometimes if it gets really fucking wet, and which it does, because it will get these crazy heavy rainstorms, you can get leaves. You can get fusarium or pythium, root rot, and these protect from those types of conditions. So not only that, they cycle nutrients, they release beneficial plant hormones. Yep. Yeah, if lead are well, so you have to think about this, right? So think about the rate of growth that kelp does. It can grow up to 4 feet in 24 hours. Some cases even greater. They're bioaccumulators. Kelp is accumulating all of the disgusting shit that is in our oceans. And then if you're using that as an input, you have to remember, like, okay, here's a good example. I was at the lab that I used yesterday. They're building a whole new science lab. They're environmental ISO certified. They work with the EPA and they regulate corporations' runoff, and they look at things. So what they'll look at is, like, they'll take microorganisms, microflora and fauna, and they'll culture those types of things in runoff water, and then they'll feed those to another organism that's slightly larger, and they'll gauge how much of those toxins are actually being transferred through the food chain. The same concept applies in the soil. So if your food chain contains a bunch of shit that you don't want in there, it's getting liberated into that soil system. The plants are observing that, and then you're either consuming it or you're smoking it. So you have to be really careful about the inputs. And I've done a ton because we build soil, and we've had to look at tons and tons of different sources of inputs so that way we can mitigate those impacts. Yep. Cut off kelp extracts too high in heavy metals. Alfalfa is good, and the thing is, like, I use, for my nitrogen inputs, I'm usually using blood meal and alfalfa meal. Blood meal has the highest percent of nitrogen, and it also is the fastest to be liberated. It's typically about 90% solubilized within a matter of 10 days, given that you have the right soil conditions, hydrology, temperature, etc. Alfalfa meal usually takes 3 to 4 weeks to break down 80%, so it's more of a slow release. Yeah, definitely ocean inputs are one of the things to think about when we're talking about inputs. But, again, one of the things is, if you're thinking about kelp, right? What are the benefits that you're getting from that kelp extract? So there's small amounts of nutrients, and there might be, depending on how it was processed, maybe some phytohormones, some beneficial compounds. But this is what I use for that. You know what I mean? Because we're talking about microbial fermentation, and during the fermentation process, when these microbes are consuming the carbohydrate, they're creating a lot of these enzymes, amino acids, all that stuff. Phytohormones, and then when you're inoculating your media, you're not just inoculating with the bacteria and the fungi, you're getting all of the compounds. That's what's so great about, like, the Microbe Plus product, right? You're getting phytohormones, you're getting siderophores, you're getting different types of enzymes, you're getting different types of proteins. You're not just getting the microbes themselves, you're getting all of the compounds that they just produce while they were doing the fermentation process. I'll take you guys over there here real quick. I actually just started some fresh batches. It usually takes about 2 weeks. I'll show you guys some of the fermentation tanks we got back here. So let me see, I'll turn this around real quick. So we just got some fermentation tanks right here, and let me open this up. It's on there pretty tight. You can see all those bubbles. That's all CO2 being released during fermentation. So we like to keep this on real tight. Let me turn my camera back around. But this batch is about 1 week old today. It's actually exactly 1 week old today. But what's happening is, over the course of the 14 days that the microbes, because we start it with the spores, right? Just like the trichoderma and the bacillus subtilis. So we start with that spore, and then we add our carbohydrate. And during the next 14 days, what's happening is all those microorganisms are converting that carbohydrate into beneficial compounds. So you get the consortium plus all the benefits that they made. Blood meal has a large furry issue. Yeah, it does attract critters. It absolutely does. My dog, if I have a bag of blood meal sitting out, he'll try to get in there and eat it, and he gets it all over his face. And, he's a big old messy bulldog, and it's gross. And it smells strong too. It's super, ammonia. But that's the benefit that it's bringing in, So if you guys have any other questions, just shoot them. Remember, if you guys are doing anything outdoors this season, even indoors, I use them indoor as well. Not as frequently indoors, usually 3 times per cycle. Indoors, they're very efficient, and because we're not dealing with all of the environmental parameters that we do outdoors, once mid-veg, once that transition, and week 2 of flower, spray and drench your media. And you shouldn't really have to, as long as you always do those protocols, and that's part of your integrated pest management practices, you probably never will run into, powdery mildew or bud mold or anything like that. Outdoors, I like to drench throughout the season, spray and drench throughout the season. What's the shelf life on the trich and the bacillus spores? So this is really, really cool, right? So if I was to keep this little thing just, in my cupboard, I could pull this out 5 years from now and it'd still be good. What I do is I tell people 2-year shelf life, but I have literally used microbes that are older than that, and they have found bacillus species in the permafrost that is 35 million years old that they were able to culture in a petri dish and bring right back to life. The cool thing about these, they create what are called endospores, and what they do is once they are in environmental conditions that aren't conducive for growth, like water limitation, carbon limitation, nutrient limitation, they'll actually encapsulate their DNA into a spore, and it is protected with this like lipid bilayer, right? And so it protects it from extremes in temperature, cold and heat, pH fluctuations, and then when conditions are right, these things can just turn back on and do their thing. So the only thing I have to say though is as long as you keep them in a cool, dry place, they will last a very long time. So if you needed to get like a whole case, because you're like, hey, I'm going to be using this frequently throughout the whole season, and you wanted to save a little bit, yeah. Oh, what up, Dirty the Grower? How's it going, buddy? Let's see. Anyway, I'm going to hop off, you guys. Thanks for joining. You can find all of the products on the Bokashi Earthworks website, and I'm going to keep doing these YouTube lives since IG's got me banned. Alrighty.